when RE was born, software looked like this, right? Let's say that RE was born together with software engineering, which was 1969. So basically, somewhere here there was the requirements analyst, requirements guy doing the requirements work, okay? And the reason why I'm bringing this picture is that there has been a fundamental change, and a lot of changes, and you know all that, during the years, which kind of impacted the way how we do requirements engineering, but at the same time the fundamentals of requirements engineering kind of wanted to remain stable, which is the case for any discipline to kind of grow and become the mature discipline. So 1969 was the first NATO conference when the software engineering term was coined. I just dig up some pictures of the software engineering conference. We see nice woman, right? A guy that is trying to do some kind of coding, right? And a guy who is even more hardcore coder, right? So when they started the term software engineering, my kind of interpretation why they did that, and I think it was Barry Beam's main fault. Anyone knows who Barry Beam is? Probably yes, right? He's the kind of the main figure behind software engineering, was that they had to figure out the way to actually get paid for the work they were doing. So they were just the happy hackers doing this funny machines, and then they wanted to find a way how they get paid, basically from NASA and other big companies, Department of Defense. So let's write a contract and just get paid for what we do for the contract. That was basically the idea for software engineering. And of course, there was not that much open source software. No free software, no guy that is actually working for free for you and producing the software. And it sort of stopped working after a while, right? And this is why I had the title about can we do requirements without requirements? Or can we even do software engineering without engineering? So it's like making an omelette without eggs, or probably you know these two pictures as well. I really like them because I think I'm a true engineer. I mean, my wife is a musician and I really love her, but at the same time I'm telling her every time we fly somewhere, I'm like, it's us engineers. It's not you musicians that made this fly, okay? The question is, can we make this without having this very heavy engineering approach that is very matured, very rigid, and really, really kind of very often boring, right? Let me try to answer it later on. A quiz for you. What are the two main things that these things have in common? Except from the authors are actually dead. Okay?
Ratings?
Yes, yeah. No, not really. I even brought a Swedish example, and Norwegian actually, but Scandinavian. Any tip?
Creator and a consumer.
These are masterpieces, which means these are one of the kind. And so there is only one version of them. There's only one Mona Lisa. There will never be the second one. So I'm bringing this example because I see software engineers and the students that we're actually trying to educate as thinking too much about software as an art than the engineering. They write the code so that it's one of the kind, rarely thinking about what's going to happen afterwards. And of course, this can be wonderful Pablo Picasso, but in reality, this Pablo Picasso has to be changed 1 zillion times the next 10 years. And then after that, you put some kind of summary of students to fix the bugs in it. So that is one of the reasons why when the software engineering was created in requirements engineering, they thought we have to do it in the engineering way. But the number of changes and the number of versions plus the approach to do software in a kind of artistic way, I would say. I guess probably some of you will do some music or some kind of forms of being artists. It's not that easy. So let's jump to actually the actual topic of the talk, which is a successful story of RE without requirements. In anonymous company where I actually did a study. I hope this is not recording. Yes, it is. We all know this company. The company is quite successful. It was growing and it's probably still growing. And they approached us and they said, well, we actually have good products, good quality, happy customers. We're making money. We don't have any requirements process. Would you like to come and investigate that? I said, well, great. That means I can burn some of the classical books about requirements engineering if this turns out to be right. Let me walk you through the company and explain some of the results. And at the same time, I don't want to be too academic and boring and kind of read too much the detailed results. If you would like to go more into details and read this report, you can always get it from me. It's a public delivery, so it's available. So let's go through it. This is the requirements process. They have some kind of business strategy. They have some kind of roadmap. They have some kind of order. Then they put this order into a project. And then here is an interesting thing that we discovered. They have a project-specific documentation, and then they have the reference documentation. That was one of the strange things that we discovered when we started talking about requirements process at the company. This is the project-specific documentation, which, by the way, never gets updated. It's simply, I don't know, deleted, thrown away once the project is completed. We have the order, which is the fluffy kind of initial description of requirements. Then we have the project development overview, which has not that much to do with requirements. And then we have this one, which we were hoping as the educated requirements engineers, and I even have a PhD in requirements engineering, will be the key of requirements. Here I can see my requirements that I was reading about for so many years, and not really. Because this document looks differently depending on where it's organized and where it's created, and it can be like this, it can be like that, it can be bigger or smaller. And then we have the classical backlog, used as a substitute for PSR, currently being adopted in a few teams at the company. So from the beginning, there's not that much of a detailed specification. This specification grows organically in a very informal way later on. Then we have the reference documentation, which you can also call a platform documentation, which actually is not a requirements documentation. It's a description of how the software works. So at least in my understanding, that's something different than the requirements, which are supposed to describe the intentions or some kind of needs of the customer. This is basically, we have this code and it works like this. We don't know where it comes from, but it works like this. Okay? The feature description, that is also a functionality description on the similar but not identical level than the functional summary. The document is owned by the product manager organization that is more market-oriented than the functional summary organization. Only some teams have studied this document yet and even have used this for recent changes. And then we have the architectural design summary, which is describing the architectural description, giving the developers some details about the design. This document contains no requirements again. So, I mean, how they actually know that this should be 7.5 or 3.2 or 17. This is, I mean, knowing the company is rather embedded systems and rather down to the implementation level. And it's pretty much about performance. Most of the products are about performance. So they should have a lot of these requirements. Apparently they don't. I will walk you through some of the findings around the process, around this couple of boxes that they call the process. We have a vague order, which is of course unclear for the developers. And then there is a product manager role, which shows the importance of software product management, who is actually kind of translating this between the developers and the person who order it. So a tip for you is to hire a good product manager, or think at least about product management, because I believe it's getting more and more important to get a good product manager. The person needs to be available for discussion in the beginning of the development. So this initial phase is very important to put people together and really brainstorm and kind of discuss what is really the implementation details, what are really the detailed requirements, how this should be implemented, in what way, and so on. What are the usability levels, for example, that we should focus on. At the same time, what they told us is that you should not implement the details just as the system behaves exactly like the specification says. Well, then how to do that. The answer was you have to allow the team to be experts in their particular area. They know the capabilities and they know the limitations. So very often if the requirement is kind of a killer requirement, it's going to take a lot of time to implement and it's going to take a lot of resources. Maybe we should lower the expectations and implement just good enough. A lot of knowledge at this company was actually not documented, as you might imagine. If there is no real process, there is no real requirements database, and there were actually people who were championing for not having a database. I met a guy who told me in the face, if there is a database of requirements coming into this company, I will shoot down this idea very quickly. So as a requirements guy, I was like walking away from me. Okay, please, I won't say that. Why this works? I mean, the part of the documentation, the main part of the documentation that contains requirements is project specific and not maintained after the project have ended. So during this very intensive phase where you have the product manager and the development team, there is actually quite a lot of documentation. But the question is it really useful after we release the products and customers are using it? I will come back to that afterwards. Lots of tacit knowledge, lots of discussion, lots of direct communication. And here's a very important aspect. It's a very special company in the sense that all the development is in one place. We're not talking about global software development, we're not talking about outsourcing, we're not talking about cultural differences. All the companies 9 to 5, the same building, or maybe 2 now, which makes this actually to a large degree fly. Product managers and developers are the source of information before reverse engineering. So as said, I mean, they said it's actually faster to go and ask someone than to check the documentation. The question is, to what degree this works? If you actually ask a very important developer that is doing the key feature 10 times a day about a small thing, this guy has to switch the context, has to refocus, has to answer your question, plus he's answering 20 times the same question, which means he's getting irritated and annoyed. In this case, they get many questions, but they don't mind answering them. I think it's a part of the company's culture, which really, I happen to be visiting or working with many companies, and this company is special in the sense that it's kind of very, very much inspired by the idea of everyone should talk to everyone quite freely, and there are no real boundaries and as little formalities as possible. I think this is another key aspect that makes this frequent questioning kind of be okay and understood, but that it's not that much of a waste of time. If you don't know how it works, just check the code and why it works. Code has the answer. Which brings us to another very interesting aspect from a research point of view. Can requirements be close to the code enough so that we can actually trust them, or how much effort we have to put into updating them so that we can trust them? Testers get the feeling of requirements when talking to the developers, so they kind of try to understand, okay, what are you coding today and how it will look like, so let me try to write some test cases, and what do you thinking the performance will be? When we ask about quality requirements, we got the answer, what's that? And then when we ask again, they said, well, yeah, actually performance is kind of important, so number of frames per second. But yes, that's important. The other questions, do you have to really document it, which I will come back later on. They build the products on the platform, and they have an issue of actually writing or specifying the quality requirements for that platform because of the many products being developed from the same platform, many configurations. Sometimes it's half of the code that actually is put into the product, sometimes the entire platform is put in the product, which makes the performance figures much different. And also they have different hardware. Some of the hardware they actually design by themselves, some of the hardware they actually order. So there is this uncertainty if the hardware is going to meet the spec. So the answer is, if you want to know the quality level, you need to test it, you need to measure it. Very empirical way. And they said literally, If I want to know what's the performance, I go and grab an old product and I run it, and I see, and I then if I need this documentation, in a sense requirements documentation, it's there, it's embedded in the product. The question is how many old products they have to store. If there is a question from the customer, we need this performance of this product you sold us 20 years ago. Yeah, we have it in the basement, let me try to run it. So it depends. This works depending on what's your product life cycle. I know if you have a product life cycle of more than 20 years. No. So I guess yes, one person. Okay. Two. So then maybe you have to spec it, but I guess for the remaining ones, I think it would be. I mean, you can always pull up an old product and simply run it and see how it works.
They also have some kind of, as I remember doing some work on,
Mm-hmm.
that they had some kind of a gold team or something. You had to show the product, the picture, the graphical picture,
Mm-hmm.
camera, so that they would approve. So that is more of a feeling that
Mm.
the picture is good.
Yeah, so that's because performance is just one of the examples. I mean, there's a lot of other quality requirements that are very difficult to specify, even yet more difficult to test. So how do you actually go over it? I mean, you just run it and show it and see if that's the acceptable level.
But I think it's a specific product, special product that they have, which it's rather complex inside, but rather should be quite simple
On the outside.
Yes.
Yeah, that's another aspect. You have to remember this is a company that works very little with user interface and how the interface should be user friendly. A lot of the stuff is kind of embedded, and that's why they can get away with very limited documentation, because as long as they have a guy working for them that they can grab and that can explain how it works, there's not that much need for documentation. Here is an interesting finding. Requirements are usually expressed in a comparative way using existing functionality and quality properties as a benchmark. For example, I need to buy a new phone, I just want this to be better than the old one. This is the only requirement I have. Should be as product-wise, and I will come back to this as, because as brings us to the very interesting aspect of requirements engineering that we are currently researching quite heavily. And then there is a requirement about backward compatibility, which they again test by pulling the product and checking if it's going to work on the old product. And this is actually a solution that is quite scalable, I would say. I mean, I'm actually doing some work with Sony Mobile nowadays, and for them to take an Android release and try it on, let's say, new hardware, it's a matter of days rather than months. I'm sorry, I cannot say more details because I think I'm breaking the confidentiality. But you would be actually quite surprised that this kind of hacking approach, if needed, is not that time-consuming and that expensive. The product should work exactly as the old one, brings us to a concept that I call stakeholder inertia, which is simply speaking, I want my new phone to work just like the old one, but to be better. There are certain requirements that you shouldn't change. For example, this is Citroën dashboard, this is BMW's dashboard. Citroën is losing market, BMW is making a lot of money. Because BMW customers want to have the same dashboard, and Citroën is kind of creative in their own way, which scares the customers away from them. Another good example, when this ribbon was introduced, there was a survey that said it's actually decreasing productivity by 35%. I have a borrowed computer, I broke mine last week. I have Office 2013, I hate it. So it's a response to evolutionary change. There is sequels in the entertainment industry as well. And then we have the best example, which is iPhone. There's very little innovation in between the iPhones. Of course, they sell it as, I give you the new iPhone. but they really thought this through, how they should do requirements engineering so that they actually don't do too much so the customers go for the competitors. But very often the curve looks like this. We want more features, we want better features, we just want to have as much as possible, which increases the complexity and also puts a lot of work on requirements engineering. The problem with benchmarking is that the old system works as it was intended, or is it just some kind of going away from the requirements? So since you don't have requirements, you never know, was this spec or was this the result of happy hacking 1 week before we shipped 5,000 products to the customer? This you always have to figure out when you do this kind of reverse engineering. It's hard to test the difficulties, understanding what includes the piece of software. Some parts are used, some are not used. That brings another problem of okay, how we can test this one. How am I doing with time? I think our host just. So how much do I have? I have 5 more minutes. Really? Great. Because I'm starting to get a little bit stressed. So it's good. Maybe the way forward is to just specify the delta. Any of you specifying requirements simply by saying, this is the difference from the old product, this is the difference from the old platform, this is the difference? Because actually, yeah, oh, thank you. That means it's not the stupidest idea in the universe if someone uses it. That could be a way forward. I mean, think about the number of duplicates in the requirements database. They simply describe the same thing. And also about obvious requirements that, for example, a mobile phone should have the functionality to make the phone calls. Yes, we have that. We have had that for 20 years. Let's focus on specifying the deltas. That could be a good way to reduce complexity and also to get away with limited documentation. The problem still remains here. If we only have the information about the deltas, we don't really know where this requirement comes from. We just have the information about that it's getting better and better or worse than the previous one. But why we have this one there, no one knows. What are the implications of their way of working? When it comes to understanding the behavior of a feature, they have troubles in knowing what the behavior of a feature is, especially testers and quality assessment. They file a lot of incorrect bug reports because they don't know, is this the way how it should be working or not? And since this work was done under a master thesis, their company supervisor was one of the guys who was actually mostly working with this. So he was mostly very, very annoyed about that. But here is the balance. I mean, can we afford having this annoying bug reports every now and there, or should we just put all the effort in documenting the stuff? In their case, they decided to go for being a little bit annoyed, but not necessarily documenting everything and updating, because documenting is just one effort. Updating is usually much bigger effort because it's much more stretch in time. Understanding which functionality is included in a piece of software. Again, it was very challenging. There are different versions releases. Challenging especially when testing is so-called benchmarking requirements. At the same time, if we think about reusing open source software as a kind of ready solution, which comes with some kind of set of requirements and capabilities, one way of doing that is simply focusing on if the parts of the software that we want to works, and then the rest we can simply try to ignore or switch off. Complementary information about requirements. It is very difficult to know why a feature exists, how important it is or was, and why it was chosen to behave in the way it does. Here again, if you have a product life cycle of months or years, and you know you will be replacing the platform every couple of years, then you can probably not spend the time on documenting that. But if you have much longer product lead times and product life cycles, then it's probably better to focus a little bit on that aspect as well. Choosing what test cases to run. as far as we understood, the testing is there is a lot of testing done, much more than requirements. If you compare the effort, they even said that they spent. If we say the total effort is 100%, they spend 10% on requirements and 90% on testing. I'm sorry for that. But the reason why they succeed is that they have everyone in one place and in one location. What I actually advised them, of course, was to change this balance a little bit and actually put more effort on testing. I haven't said you should do another way around, 90% requirements, 10% testing, because there will be only requirements and no real product. But this 10% felt like if they're about to switch the platform, which they are very used to use, which they might have to be forced because of the external forces and maybe a new player entering an ecosystem and saying, here is an open platform. Go ahead. Anyone who wants to make a similar product, please. Just like it happened for Sony Mobile with Android. Then it would be much more challenging for them to understand what kind of capabilities they want, if they can go for that platform or not. If it will match, then they will have to hack everything from the plain vanilla version. There's no traceability between tests and requirements. So in any case where this kind of traceability is required by certification authorities or something, they cannot really provide that. But on the other hand, the quality of the developed software is good. So this is actually where I should burn all the requirements engineering books, which say if we don't do requirements, you're going to end up with lousy software. Which brings us to a very interesting discussion point, which I hope we can discuss today. What is the requirement today? What is requirements engineering today? Because I believe it's still there. It's just changing its shape a little bit, and it's kind of in different contexts and aspects showing us different faces. The question is, as I said, what should be the healthy balance between RE and testing? And this is something we are now at BTH investigating a lot. Because as you are profiled requirements and testing, this is a great profiling, because they should go ihop, as you say it in English, in Swedish. The question is, what's the balance, depending on the company, the type of products, the product life cycle as well, and also some kind of strategic plans. This is something we are investigating right now. I don't have a good answer, but I can give you homework. Try to check how much it is at your companies, and if you're really happy with that, and maybe it's healthy or maybe it's unhealthy, and maybe send me the feedback or us feedback to Sarah, and we can start a discussion. Okay, at this company we have 50-50, but it's not good. You have a question?
Well, no. In my opinion, I think it's companies tend to put a lot less effort in requirements than they should be doing. Actually, they tend to test a lot, but that's because they have lots of requirements from the get-go, basically.
But sometimes I wonder what is requirement. So if we widen the definition of it, because if they put a lot of effort in test and have well-defined test, and maybe they discuss the testing levels, for example, then you kind of.
This is requirements communication in the classical sense.
But it's maybe more driven from the test department to set certain requirements.
I think this 10% is the effort on writing this initial requirements and then storing this reference documentation. This is what they understood. Because if we count the communication of requirements, all the work between product manager and the initial phase, and then later also getting all the feedback, this can be up to 60-40, 50-50 in my kind of, according to my estimate.
Because it might be, for example, that you invite developers to review system tests, and that is basically they don't have a requirement that they use as a starting point instead.
We asked them about scalability because we knew they're going to grow double digits. I don't know what's going to happen right now because of the buy offer, but let's say they continue to grow, and not many were concerned over the scalability issue. At the same time, they said, well, if we design and put the process in place and start documenting, we have the issue of changing processes, which we can never follow up. So our reference documentation, so the requirements documentation for the core, is stable, and we have a very rigid process of adding or removing changes to the documentation, and this is what saves us on our product development. Because at least we know that the core works like this, and then what the actual projects do with particular products is kind of less important and less disturbing. I would say they're very dependent because they are situated in one place. Once they start doing offshoring or maybe sending half of the development effort abroad, they're going to face a lot of challenges. We just run a study in a company nearby about offshoring and knowledge exchange and communication patterns in offshoring, and it's a lot of interesting things that actually start to happen in this situation. Face-to-face discussion instead of documenting, yes, works for certain levels, certain details, certain levels. So again, there has to be a balance. What do you actually should write down and what can stay in someone's head? High-level requirements quite stable. Lower requirements not important enough to be documented. So the implementation details, because here you have a trade-off between if I put a guy for half a day to figure this out, or if I put someone to actually maintain the documentation. What's the best decision given the fact that I will need that knowledge or that information twice a year or twice a day? If it's twice a day, then maybe it's better to document that in a more appropriate way. If it's twice a year, spending one man's day twice a year or figuring something out doesn't seem to be a big problem. Okay. And this brings us to another study that we actually did, because we started touching upon what you should document, what you shouldn't document, what kind of requirements are important. We actually ran a survey among over 200 companies asking when requirements grow old. Because we got inspired about, I found in Sony Mobile's requirements, in the Sony Mobile's database of requirements, for example, the phone should be able to make phone calls. So, obvious requirements. We defined the obsolete requirements as no longer required for current release. And we asked 200 companies, over 200. And what is interesting is that almost 80% actually said that this has actually quite negative impact on requirements engineering process. And I don't know, maybe some of you have a database with a lot of old stuff that is just there because it's good to have. Because if we eventually have some time and some energy, we might implement this requirement that we actually put 5 years ago. Never seen this happening. So maybe it's time to clean those requirements. We did a very nice plug-in to Doors, and we run it a couple of large projects, and we found that you can very simply clean the old requirements using that plugin. It's a very interesting stuff. You identify them mainly manually, the old requirements, and you mainly manage them manually. So here is a potential for some kind of methods and maybe some kind of plugins or something to do obsolete requirements identification. And thanks to that, help your requirements process to actually focus on the right things and get rid of some of the old stuff. So what is a requirement? Getting back to your question, which is almost the last slide. So I hope there's pizza still. We all know open source software. We all know that in open source software, code comes first. If I have a great idea, which is kind of, I don't put a requirement on someone else working in open source software. I simply sit on my butt and try to code it. When it's done, I can spend some time on documenting how it works. Question is this a requirement? If you listen to some of the outsiders from the requirements engineering research field, they will say yes. And I have to agree with them. The requirements in this case are just the descriptions how it works. It's not even recipes how you actually code it. It's the descriptions. This is the function. This is how it works. So that's the first answer. Of course, we have market-driven requirements engineering. I guess most of you probably do products that are sold on the market, to the open markets. Then the customer response is actually what matters, and the experience is what matters. I'm not that particularly interested what kind of requirements they put on the new phone. As long as I like it, then I will buy it. Which brings us back to the aspect which is very often overlooked about inertia. Very often we do slightly too much of requirements engineering in terms of new features, and we completely not focus about let's do not touch this feature, it's good. Because people will get more annoyed than actually happy that we implemented it. Which is also requirements engineering work. How to bring new innovation at the same time not breaking down the old one. I mean, probably some of you have Apple, they are really good at it, in my opinion. So this is exactly the aspect I was talking about inertia. Then we have another aspect, which is software is a great enabler of innovation. And of course, without software, we cannot sell our products. But it's more and more commodity with very little value. We get a lot of open source. We can download things. So the question is, if it's a commodity, do we really have to have the closed requirements databases on software or software-related parts that will simply be locked down in our kind of companies, and no one really knows what we are working on?
I was thinking with this market-driven requirement, that there is a difference if it's if you're offering an off-the-shelf product, or if you're doing a product for a specific use, just for a specific customer. And the case with Access is that they have more off-the-shelf product, and in that case they can decide themselves. So the product can make decisions.
Yeah. Thank you. I forgot about one thing. They are or were or are market leaders. And that's fundamentally changed the way how you can do requirements engineering. Because if you can dictate the rules just like Apple does, then Apple's requirements engineering looks very different. I don't know if you're familiar with the story of introducing iPhone. It wasn't that good. The spec was not that good. But they actually dictated to the operators that the operators have to subsidize it and it has to be flat rate. Otherwise, the customers don't get the right user experience. So their requirements engineering work was actually on focusing on user experience and forcing the operators to subsidize it and to provide flat rate for data.
But if you're requesting a specific product, then that might even be integrated in your own product. You need to be more kind of specific.
Of course, because you have to know how to integrate it. But if you are running one-time show, making a lot of money on that, then maybe you can get away with limited documentation because you know it's not going to be reused that much for the future businesses.
Yeah, or get away what Access is doing, that they want the experience to also be good. The outside to be good.
Pete says here, I have two more things to say. I have this crazy idea of open requirements, opening up requirements databases. I start to see this happening, which is basically one company is working on a feature and is teaming up with another company saying, well, can we do this together? And we make a deal that we take the first 3 months of the market because we actually have a product about that in the pipe, and you can be the second in the market, which means you get the second part of the cake. Connecting this with the fact that a lot of requirements get obsolete quite frequently, and in 6 months they are actually not that hot anymore, and that there is this inertia factor. Maybe opening up some parts isn't that stupid idea. And also, if requirements are obvious, a phone has to make a phone call, a plane has to fly, an engine has to use as little fuel as possible, then why making this whole buzz about secrecy? Then requirements are more low-level kind of design, closer to the design. As said, maybe we can define our requirements, do the requirements work with the competitors? And here I can just say a little bit about our wonderful research project, which actually turned out to be a process improvement product with Qtema. So I'm proud to say that at BTH we actually work in close collaboration with industry, and then some of the effects of that is that the companies we work with get this as the first customers, and if it works, then we kind of team up with maybe consultancy companies on doing the full technology transfer. Some of the happy customers that actually use that, we are super proud because we get more empirical data. We can discuss our things, and everyone is happy. So that said, if you have any further questions, please contact me. I guess this email is the easiest one. This is the hardcore email. So if you manage to send me an email, I will really appreciate that. And the Gmail is the one that I'm probably answering the fastest. I will stay here. I will really appreciate the discussion. And thank you for listening.